The first thing we are going to do is to select this face in the solid and move it by y minus 2 millimeters. You'll see that this brings it to intersect with this bottom cutout region, and we can use these buttons to scroll through the various trimming options. When you move a face in the solid, there will often be more than one solution to the retrimming of the extended face. Once we reach the solution that we're happy with, we can close the form. And we also want to drop the bottom of this pocket by 10 millimeters. We want to maintain a wall thickness at the bottom, so we're going to select the top and the bottom face of the pocket and move them both down the Z axis. So we can see we have dropped the bottom of that pocket, but we've maintained a wall thickness. Next we're going to edit this slot. So I'm going to first of all place a work plane in that slot using the intelligent cursor to position it between two key points. I can then use the drag handles to align it to this face. We can rotate the model around for a better view and zoom in and select the faces that we want to edit. First we're going to scale the slot in size, so shrink the slot. Once we've done that, we are going to rotate it so that it is approximately parallel with the surrounding features. I'll return to the world as the active work plane, and there are a couple of areas of the model that we no longer require. So we can just select those and remove and heal these areas. Flood fill that selection, and again just remove and heal that area. Next we're going to turn the model over and have a look at doing some edits on the underside of the model. The first is looking at editing this rib. To do that, we first want to split the top face, as it is one continuous face at the moment. We can do that using a piece of wireframe and by using the new button on the solid toolbar, and that is splitting a face of a solid using a piece of wireframe. Once we've split the face, we can drop this region. If we just get this toolbar correct, drop this region by 2 millimeters. We can then select all of the faces of the rib, and use the rotate function to rotate around this outside boss. So we can dynamically rotate, or I can input a geometric value and rotate it by that value. Next we want to apply some draft onto the side of that rib. So we go into the drafting form, select the top face as our reference, and we can dynamically alter this rib. So I'm going to set the draft to be about 2 degrees and apply that change. Once we've done that, we have seen now the splitting of a solid face using a piece of wireframe. So another new feature is if we look at the side of this, we can see these two bosses are sticking way out past the bottom of the model. So to stop this, we can select this face and then just use our normal splitting tool to split the solid based on a selected face. So this is something people have asked for some time, but is a very powerful tool that also has a lot of implications when it comes to modelling electrodes. Another area of the model we need to update is here. We can see this rib hasn't been finished off, and it doesn't intersect with the side of the model. So we can simply select those faces and extend those through the model, and PowerSHAPE is clever enough to work out a solution where it re-trims the faces of that rib to the surrounding area. So there are obviously other solutions that we could scroll through, but in this case the first solution is the correct one. Now we just saw some very simple trimming. We just saw some very simple drafting. We're going to look at drafting a more complex area of the model. And to do this I need a few things. First of all, I need some simple wireframe. So I can use the intelligent cursor to sketch some wireframe. And I also need a work plane. So I'm going to align a work plane to this geometry. Once I've done that, I'm just going to hide the solid from view, convert the wireframe to a composite curve, and create an extrusion surface from that. Now we can select all of the areas of the complex region that we want to draft. So what I want to do is draft all the way along this very complicated rib section. So I select all of these faces, and you can see we're also getting the region of the rib that goes around the 90-degree corner. I'm just going to align that for a slightly better view, and go into the drafting tool. A reference entity this time we're going to set as a surface. So we're going to use that surface that we just created. Now PowerSHAPE is calculating whether it can perform this operation now. So we'll see the ghosted blue image if it's capable of applying the draft. As I say, this is quite a complex drafting operation, and you can see that it even goes around that 90-degree corner and applies draft to both sides of that rib. Let me just apply that and dismiss it, because not only are we applying draft into a complex region, but we're also applying draft with reference to a variable z height. So we may have originally been able to apply this draft, but it would have all been referencing from one single z height. So by the time it got down here, these surfaces would have been very, very thick, because they would have been referencing this very tall z height at the start of the model. And before we move on from that, I am just going to take a quick cross section through the model so you can see the changes that has made. So if we look at the rib, we can see the draft and how it has been applied to that rib. So the next thing we want to do is we can see that the bottom of the model has nice form to it, and these sides haven't been finished off, so we want to trim these back to a nice shape of the top surface. To do that, I am going to activate the world work plane and view the model from the side, and also lock the working plane. Then we're going to do some simple wireframe sketching, so a couple of simple straight lines and also a couple of simple 3-point arcs. So we can use the intelligent cursor to find tangents and to pick the correct points, so we're just creating it roughly equidistant to that fillet. So input more geometric values, and again meet the tangents and just approximately get that curve in the right place. Once we've done that, we can convert the curve to a composite, view from the side, and then use that curve for an extrusion surface. extend it all the way through. If we just roll the model over, the solid is active, so we can select the surface and just remove that surface from the model. So we get this nice curved shape to the backside of our model. Now, quite often with these kind of plastic components, we have a small step or lip around the outside, and that is so they can clip into another part or can meet up with another part more efficiently. So I'm going to show you a very quick way of creating this. To do that, I need a simple wireframe curve, and I'm just going to take that curve and offset it by 1 millimeter. Once we've offset the curve, I can group select all the top faces of the solid and use the button that we saw earlier to split the model using a piece of wireframe. So splitting that top face, I can then go around and select all of those top faces. So I can select that one, and I think there are about 3 or 4 faces to select. Once I've selected all of those faces, I can go into the Move feature and raise them all by 1 millimeter. So we create what is effectively a very complex 1 millimeter step all the way around the model. But we do this in a very, very quick and efficient way. So if we think about it, that step would be very hard to create in any other way than the way that we've just seen. So once we've finished the sort of basic modelling operations, we'll take a look in our solid history tree, and we can see that we are still working with a completely dumb solid. If we remember, we brought this solid in as an XT file, so it could have come from any PowerSolid based modelling system. So we have no history. Now there are various features that we can see in this model, and there are various reasons why you would want a feature-based history tree. The first of these would be for machining. So if you wanted to pass various features along to PowerMill, you would need to have them recognized in the solid part first. An example of this would be a hole feature. So we could go into our hole feature tool, and on all of the feature forms now you will see this new button which changes the mode from creation to recognition. And this means we can recognize features in dumb geometry. So I've clicked on that area, PowerSHAPE has automatically recognized that as a hole feature and built that into the tree. The beauty is we could pass this to the CAM system, but we could also easily edit or suppress that hole feature. So if we just reapply that hole feature. Now whilst we're here, I have noticed there are a couple of poor quality areas in the model. So I'm going to come back and look at fixing those in a few moments' time. So as well as holes and passing them to the CAM system, you may also want to build features so that you can quickly and easily update those areas of the model. And as I say, we can do this for pockets, bosses, cuts and so on. So if we look at how we would recognize a solid pocket, come into the pocket form, change the mode to recognition, apply that, and it recognizes that area of the solid as being a pocket feature. Once we've recognized it and have it in the tree, it's very quick and easy to come in and modify that feature, either dynamically by dragging the feature around, or we can type in geometric values and quickly update or change the model in that area. So we have holes, pockets, bosses, cuts, etc. But we also have the ability to recognize solid fillets. So remember now, we don't have any fillets in the tree, but we are picking up and recognizing the geometry as a fillet, and we'll add it to the tree. Now I could leave it as a recognized 8, or at the point of recognizing it I could also update that fillet. So I'm telling it recognize that area as a fillet and actually change the fillet to be 10. Now whilst we're in the form, I could switch back to the other mode and apply some new fillets if I wanted to, and obviously these would also go into the history tree. So we mentioned earlier there were several faults in the model. Now the problem is, if I start doing pulling surfaces from the model or doing direct modeling changes, I am very likely to lose the history tree. Obviously sometimes you may want to keep this history tree. So let's look at a way we could work where we can keep the history tree and still perform edits like direct modeling and removing surfaces from the solid. If we look at the solid, we have the base solid, so the point where we started, and we look at all of the history afterwards. So to do this change, I'm going to take the base solid and take a copy of it and perform these changes on the base solid. So copying out the solid now, and I can just hide the solid with the history from view. And just look at the base solid, we can see all the features have been removed from it because it is just the base solid. But I'm going to select it and run it through the solid doctor. So solid doctor is going to find 1 or 2 faults in this area, and we're going to be able to use the tools available to us in the solid doctor to edit and fix the model. So it's found a large vertex in this corner, but also visually we can see there are some areas where the surfaces just aren't very good at all. So what I'm going to do is select all of those surfaces first of all and just use the solid doctor to delete them. Once I've deleted them, I can recheck the solid, and it should recognize that we have a big hole in the solid. Now here's the interesting point, folks, in that if we were using another solid modeler, we would be getting pretty stumped by now as to ways of repairing and fixing this. But the fact is that with PowerSHAPE you have all of the complex surface edit tools, so you can always fall back on those, extract areas of the solid model and use surface modeling to fix even the most complex of faults. So it's recognized a large hole. I'm going to fill that hole with a non-tangential surface. So we can see one nice smooth surface to replace all of those horrible ones. Then we'll go back to the large vertex and say extract the surfaces around that fault and edit them. So there's only one that I'm particularly interested in, so I'm just going to select that surface, hide all others, and then view from the side and zoom in. Then we can see it's this spike here that is causing us the problem. So I'm going to use a simple piece of wireframe, position it, then extend it, and then I'm going to use a trimming operation to cut back the surface in that region. Once we've done that, we can select all of the surfaces, hit the green tick, and we will sew them back into our solid model. Now if we hit recheck, it should tell us that we now have a faultless parasolid model, or that all faults have been fixed. And it's then going to automatically close the solid doctor for us. So all faults with the solid have been fixed. So we've fixed the base solid. If we redisplay the solid with the history, we can come to the base solid in that tree, say modify, replace the solid, select the one that we fixed. So we're now plumbing the faultless parasolid back into this history tree. So we now have a completely faultless solid, but we have maintained the solid history. If we look at that area, we can see it's all fixed up and much nicer. And if we run it through the solid doctor, it would tell us that we have no faults. So the final step is to select the model and just mirror it about the YZ working plane. And once we have mirrored it, we can select the mirrored version and just add those two solids together. So you see we have the completed parasolid model. I've highlighted a variety of direct modelling tools and ways of recognizing features and working whilst maintaining a history tree.